Have you ever looked up at the sky and wondered if something incredible was happening above your head without anyone noticing? Imagine waking up to headlines suggesting that the sky over Earth seemed different on July 2nd. Scientists around the world rushed to analyze data from satellites, observatories, and space telescopes. While the average person saw a familiar blue sky during the day and stars at night, sensitive instruments detected subtle changes that sparked intense discussion among researchers. What exactly changed? Why did experts react so quickly? And could these mysterious observations teach us something new about our planet and the universe? The atmosphere surrounding Earth is far more dynamic than it appears. Every second, it is shaped by solar radiation, charged particles, magnetic fields, and interactions with space weather. On July 2nd, several monitoring systems recorded unusual variations in the upper atmosphere. Some instruments measured changes in the ionosphere, a region filled with electrically charged particles that plays a vital role in radio communication and GPS signals. Others observed unexpected patterns in Earth's magnetic environment. While none of these changes posed immediate danger, their timing and unusual combination captured the attention of scientists worldwide. Researchers immediately began comparing information collected from weather satellites, solar observatories, and ground-based monitoring stations. Their first priority was determining whether the sun had released a burst of energy capable of disturbing Earth's magnetic shield. Solar flares and coronal mass ejections frequently influence our planet, sometimes creating brilliant auroras while disrupting satellites and communication networks. However, the available data suggested that the observed changes did not perfectly match the typical signatures of a major solar storm. This raised new questions and encouraged scientists to investigate additional possibilities. One theory focused on invisible waves traveling through the atmosphere. Massive weather systems, volcanic activity, and even powerful earthquakes can generate atmospheric gravity waves that move upward into higher layers of the atmosphere. As these waves travel, they influence the density and electrical properties of the ionosphere. Scientists wondered whether an unusual combination of atmospheric conditions on July 2nd had amplified these effects beyond what is normally observed. If confirmed, it would demonstrate how closely Earth's weather and space environment are connected. Another possibility involved Earth's magnetic field itself. Our planet's magnetic shield is constantly shifting and responding to forces originating both inside Earth and from the sun's sensitive magnetometers occasionally detect subtle fluctuations that reveal complex interactions occurring thousands of kilometers above the surface. Researchers carefully examined whether July 2nd represented a rare alignment of magnetic conditions rather than an entirely new phenomenon. Even slight changes in Earth's magnetosphere can produce measurable effects for satellites orbiting the planet. The growing network of advanced satellites made this investigation especially exciting. Decades ago, many small atmospheric changes would have gone completely unnoticed. Today, hundreds of instruments continuously measure temperature, radiation, particle movement, atmospheric composition, and magnetic activity with remarkable precision. This enormous flow of information allows scientists to identify tiny anomalies that once disappeared within the background noise. In many cases, discoveries begin not because something dramatic happens, but because technology has become sensitive enough to notice previously invisible patterns. Experts also examined whether cosmic rays played any role. These high-energy particles arrive from distant regions of our galaxy and constantly interact with Earth's atmosphere. The public fascination with the event also revealed something important about scientific discovery. Many people imagine breakthroughs occurring in a single dramatic moment. In reality, science often advances through careful observation, collaboration, and patience. A small anomaly detected on one day may inspire months or even years of research before its true significance becomes clear. Every unusual signal represents an opportunity to test existing theories and improve our understanding of how Earth functions within a larger environment of space. Scientists emphasized that there was no reason for public concern. Earth's atmosphere and magnetic field experience natural fluctuations throughout the year. What made July 2nd remarkable was not evidence of danger, but the opportunity to study a rare combination of conditions with modern technology. Each new dataset strengthens forecasting models that help protect satellites, communication systems, aviation, and future space missions. The story of July 2nd reminds us that our planet is never isolated from the universe. Invisible forces continuously shape the skies above us, connecting Earth to the sun, distant stars, and the vast expanse of space. Even on seemingly ordinary days, remarkable processes unfold far beyond human vision. Every observation brings scientists one step closer to understanding these hidden interactions, proving that the greatest discoveries often begin with a simple question: what changed and why? As technology continues to improve, the sky above Earth may reveal even more extraordinary secrets waiting to be uncovered. A mysterious change was detected on July 2nd. Scientists observed unusual variations in Earth's upper atmosphere and ionosphere using satellites and ground-based instruments, leading to global scientific investigation. Imagine waking up on July 2nd to reports that something unusual had happened high above Earth. While the sky looked perfectly normal to most people, scientists monitoring the planet with advanced satellites and sensitive instruments noticed subtle changes that immediately caught their attention. These changes were detected in the upper atmosphere and the ionosphere, a region filled with charged particles that plays a vital role in radio communication, GPS navigation, and satellite operations. Although the differences were invisible to the human eye, the data suggested that something out of the ordinary had occurred. Researchers from observatories around the world quickly began comparing measurements collected from space-based sensors and ground stations to determine whether the observations were genuine or simply the result of temporary instrument errors. As more data arrived, it became clear that multiple monitoring systems had recorded similar patterns, making the event worthy of serious investigation. Scientists emphasized that there was no immediate danger to people on Earth, but they recognized the importance of understanding what had triggered these unusual atmospheric variations. Every unexpected observation offers a valuable opportunity to learn more about the invisible forces constantly shaping our planet. The discovery reminded researchers that even on an ordinary day, Earth's atmosphere can produce surprising phenomena that challenge existing knowledge and inspire new scientific questions. Several natural explanations were explored. Researchers examined possible causes, including solar activity, atmospheric gravity waves, Earth's magnetic field fluctuations, and changes in cosmic ray intensity. After confirming that unusual atmospheric changes have been detected, scientists turned their attention to identifying the possible cause. One of the first explanations they investigated was activity from the sun, since solar flares and streams of charged particles regularly influence Earth's upper atmosphere and magnetic field. However, the available observations did not perfectly match the patterns usually associated with a major solar event, encouraging researchers to look beyond the most obvious answer. They also examined the possibility that powerful atmospheric gravity waves had traveled upward from lower layers of the atmosphere, temporarily altering conditions in the ionosphere. At the same time, experts analyzed measurements of Earth's magnetic field to determine whether subtle magnetic fluctuations had contributed to the unusual readings. Some teams even compared cosmic ray data to see if high-energy particles arriving from deep space had played a supporting role. Rather than focusing on a single explanation, scientists carefully evaluated every possibility using information gathered from satellites, observatories, weather stations, and magnetic monitoring networks around the world. This careful process demonstrated how modern science works by testing evidence instead of relying on assumptions. Each theory was measured against real observations, helping researchers gradually narrow the list of possibilities while improving their understanding of the complex interactions between Earth's atmosphere, magnetic field, and the surrounding space environment. Modern technology made the discovery possible. Advanced satellites, space observatories, and monitoring stations detected subtle atmospheric and magnetic changes that older technology would likely have missed. One of the most remarkable aspects of the July 2nd observations was that they became possible only because of today's advanced technology. Modern satellites continuously orbit Earth, collecting enormous amounts of information about the atmosphere, magnetic field, radiation levels, and charged particles surrounding the planet. Powerful ground-based observatories, radar systems, and monitoring stations work alongside these satellites, creating a global network capable of detecting even the smallest environmental changes. Decades ago, subtle variations like those observed on July 2nd might have gone completely unnoticed because scientists simply did not have instruments sensitive enough to measure them. Today, however, sophisticated sensors can detect tiny shifts that would have been impossible to identify in the past. These improvements allow researchers to compare data from multiple sources almost instantly, increasing confidence that unusual readings are real rather than simple equipment errors. Advanced computer models also help scientists analyze billions of measurements, searching for patterns that human observers could easily miss. Artificial intelligence and high-speed computing further improve this process by identifying connections across massive datasets collected from around the world. Thanks to these technological advances, researchers can investigate Earth's atmosphere with greater accuracy than ever before. Every improvement in observation equipment opens the door to discoveries that deepen our understanding of the invisible processes shaping our planet and its connection to the wider universe. Scientists use data instead of assumptions. Rather than jumping to conclusions, experts compared information from multiple sources worldwide, carefully testing different theories to understand the phenomenon. One of the most important lessons from the July 2nd event was the way scientists approached the mystery. Instead of rushing to dramatic conclusions or making unsupported claims, researchers relied on careful observation, repeated measurements, and evidence collected from multiple independent sources. Data from satellites, ground-based observatories, weather stations, magnetic sensors, and space monitoring networks were compared to determine whether the unusual atmospheric changes were genuine and to identify what might have caused them. Every piece of information was checked against existing scientific models, and experts worked together across different fields, including atmospheric science, space physics, and astronomy. When one explanation did not fully match the observations, alternative possibilities were explored rather than forcing the evidence to fit a single idea. This method is a cornerstone of scientific research because it allows conclusions to be built on facts instead of assumptions. Scientists understand that unusual events often require patience, and many discoveries take months or even years of analysis before a clear answer emerges. By carefully testing different theories and sharing data internationally, researchers increase the accuracy of their findings and reduce the chance of mistakes. The July 2nd investigation demonstrated that real scientific progress comes from curiosity, collaboration, and a willingness to follow the evidence wherever it leads, even when the answers are not immediately obvious.